this is again a video on lossless data compression. This is also based on a very simple idea which affords very excellent compression. Now, our objective is to losslessly code a value m, which is a binary number of length 2 power L dash as a value within a value s, a binary number of length L, where L dash is much larger than L. The ratio of L dash to L would be roughly the compression ratio, N or C, whatever you wish to call it. That will be N times. That is L dash is N times L. It need not be. Often quadratic and cubic orders of compression, lossless compression, are very easy to find. Logarithmic orders similar to sorting and searching algorithms, compression, lossless, are also fairly easy to find. But linear ones sometimes tend to be hard. So which is why if you should aim, always aim high. Always try to achieve more so that at least you will achieve a little less. If you keep your standards high, your chances of exceeding them are very much higher as well. If you keep your standards low, your chances of dropping below your existing standards are also very high. So always keep a high watermark when you want to try to solve a problem, to solve it perfectly. So now the idea is again very simple. The weights that you assign, these are the L bits. The weights that you assign to each of the L bit positions are 2 power from the left to right, which is the most significant leftmost nth bit, L dash times L minus 1 by L, comma 2 power L dash times L minus 2 by L, comma 2 power L dash times L minus 3 by L, and so on up to 2 power L dash times 1 by L. If L dash by L is a linear order, what you will find is it more or less preserves the deserved property of sum of all the lower weights plus 1 adding up to the next higher weight, while exactly not being simply multiplied by 2 or divided by half each time. It more or less preserves that. So the number of iterations required to losslessly code a very large value of L, say again quadratic order will be fairly possible here easily. So these are the weights that must be, that is 2 power L dash times each ith bit must be 2 power L dash times I by L. Sorry, I plus 1 by L. L minus I by L. If you go from left to right. So this more or less preserves the order.